equations here. So in our first example on the left, we have ln of 11 equals ln of 4x minus 6. Now, the base that will undo the logarithm base e is e to the. So we're going to raise both sides e to those powers. E and ln cancel, so here on the left we have 11, and e and ln cancel, so on the right we're left with 4x minus 6. Notice that this makes our problem nice and linear now. So add 6 to both sides of the equation, 17 equals 4x, and then divide both sides by 4, and we'll yield that x equals 17 over 4. X equals 17 over 4. With logarithmic equations, we must make sure that we're not putting in a negative argument to logarithm whose domain is only positives. But 17/4 times 4 is 17, and 17 minus 6 is 11. So we're seeing that this checks to be a positive number in the logarithm, so it's acceptable. Okay, now over here on the right, we have a little bit of a different sneakiness going on. The log of x, no big deal, common log is fine there, but we have the subtraction of two logs on the right. So the first thing we're going to have to do is combine our logarithms using rules. So this becomes a log of, let's see, it's a subtraction, so it's going to be a quotient, x plus 2 over the other argument, which is 2. So log x plus 2 minus log 2 is going to become a single logarithm of x plus 2 over 2. Now the cancellation, common log is log base 10, so I'm going to raise both sides 10 to those powers, so that way we cancel out the log base 10 and the 10. So we're left with x equals x plus 2 over 2. And now we're into, again, a linear type situation. So let's multiply both sides by 2. 2x equals x plus 2. Subtract x from both sides. One single x left here, and then we have a 2 over here. So it looks like we're stopping with x equals 2. Again, a quick glance makes that, yeah, legal. I can stick 2 in there. 2 plus 2 is 4. No big deal. So that's a legal answer. Okay, so why don't you try one on your own here? Try this one with ln of 6 equals ln of x plus 8 plus ln of 4. Okay, assuming you paused and tried this out, the left-hand side is fine, ln of 6. On the right-hand side, though, we have two logarithms being added. So I'm going to combine those with a product, right? So inside of the parentheses here, we need the x plus 8 and we need the 4, but we need those to be multiplied because we're adding together those logarithms. 4 times x plus 8 would be 4x plus 32. So that's our new argument. Now canceling out the logarithm base e, the ln, would be using an e. So goodbye, goodbye. 6 equals 4x plus 32. 4x plus 32. So now start to do some arithmetic here, some algebra. Subtract 32 from both sides. And 6 minus 32 should be negative 26, right? Negative 26 equals 4x. Divide both sides by 4, and it looks like we'll end up with x equals negative 26 over 4, which I can reduce a little bit more to negative 13 over 2. So it looks like negative 13 over 2 is the answer. That's negative 6.5. That's okay here, and negative 6.5 plus 8. Yeah, that's okay too. So this is a legal answer. Final answer, negative 13 halves.